Let's go on to our next talk, which is Michael. Uh, we just heard from. Michael is going to speak about transparency and maybe advisory groups. I'm just guessing.
Right.
All right, I turn it over to Michael.
Okay, I'm trying to get the screen to me. Something's not going right. Okay, I think I got it. So thank you for having me. I think this is the third session I mentioned before that I have attended and either did a presentation or watched some great presentations. I've been thinking a while. You see the gray hair. I have worked with seasonal adjusted data and reporting agencies and such. And, you know, if I thought 30 years ago, I thought models would be completely winning the game of seasonal adjustments, and they're not even close. And I had to think about why this. I'm talking to colleagues, so I'm gonna maybe be slightly provocative, but I really want to have this taken as a suggestion or a proposal and taken in the light that I know seasonal adjustment is a hard job. There's nothing easy about it. There's many eyeballs on your work. And maybe we can think of ways to get more resources or better resources to the process. So first I'll just start and just talk about issues I see. And these are really observations. One is that almost every economic process and therefore data has large and noticeable seasonals. I know we tend to do F-tests with a null hypothesis, there is no seasonal, but I think that's somewhat is besides the point. I think it's the other way around. You really should be thinking, why in the world wouldn't there be a seasonal in this economic series? And so the simple approach, and this is what I believe, at least I've read about, used to be done, just compare things to a year ago. And in fact, a lot of stores will do this. They'll compare retail sales to 12 months ago. And so the X11 was developed in the 1960s. Here, I'll tell something about myself. When I first heard X11, I had thought that the 11 meant that you need 11 parameters to estimate 12 months. And then I finally found out from one of these workshops that it came from, is it Chuck Yeager or X something jet planes? And so they started with X1 and it went all the way up to X11, and that became locked in for a while. And with some innovations, we had X12 and X13. So that was developed by Census and Statistics Canada and others. And any seasonal adjustment, you need to break your time series into three parts. You need a trend and cycle, you need a seasonal, you need an irregular. And just it should be admitted, there's really no unambiguous way to get three things out of one thing. And in fact, many people would want four. They'd want the trend and cycle split up as well. So there's really under identified system. There's no way to do this with nobody's that you would get no arguments. And so the early invitations, you know, I understand were run at night on computers. There was some staffing issues of who really wanted to work on this project. But now I think X11, X13 has been well developed and is well integrated. But still decisions need to be made. And this is one of the ideas that many people believe. If you don't have a model, you don't need to make a lot of decisions. But there's defaults, and those really are decisions. And that's why I'd say the seats type of European ARIMA approach was developed. And then the other observation is once an approach is developed, it seems to get locked in. But there's some problems with this traditional approach. One is there's absolutely no integration into any type of academic teaching of the PhD or master's systems. And then also this moving average process is very susceptible to what's called echo effects or knock-on effects, where once you have a shock, it gets propagated forward and backwards, even if it has nothing to do with seasonals. And then finally, every research I've read has said that the X11 as an algorithm tends to create moving average windows that are too short by some criteria. And what happens, you get excessive seasonal adjustments. And this you can read about or talk to Jonathan Wright in 2019. He gave a keynote address really pointing out this problem from both his own research and others. I'm not going to spend a lot of time on this. It's probably a good idea for me to at least write down how I understand the X11 process or any seasonal adjustment process. And I got to believe I probably have one or two things wrong here as I explain them. But there is a process, and that's good. And then finally, the last part is the agencies will accumulate and report all of the results. But there's some problems. I mentioned, the detrending and moving average specification can cause problems, and there's really no optimal way to do this. Again, mentioning there tends to be excessive adjustment with the X11 process. There's also this pre-testing problem. But really, I understand, or I think of the problem is often the data is treated as coming from an independent island compared to other data. And it'd be such better if there's more systematic treatment of seasonal adjustments. And then finally, there also been some research to show that there are real examples where instead of accumulating up a bunch of components that have been seasonally adjusted, it's better to do a direct seasonal adjustment of headlines, or the headline type of numbers. And I know our gentleman from New Zealand, and that was good that he talked about, they at their agency will both do the aggregate up and the direct headline and compare them to see if there's any problems. That always sounds like a good idea to me. And then this is why I'm pointing out this one here. This is the famous 1967 paper from Shishkin, Young, and Musgrave. And I did not do these underlines. This is actually, I think I got the memory right, that if you go to the census website and download the PDF, they had taken a scan of somebody's copy. And this is actually what somebody had highlighted. This is actually what I would like to highlight, that it was considered to do some type of modeling back in 1967. And these authors, these researchers concluded, if you read this last part here, that regression models just aren't sufficient enough. That's why they went to the X11 moving average type of approach. I think scientifically, or even realistically, this kind of statement is really untenable. It's hard to believe that 60 years ago, there was absolutely no series that a model didn't do good enough. That it's sort of making a claim every single economic series needs to be run through moving average adjustments as opposed to modeling. And then it's really untenable to believe that over 60 years, or almost 60 years, that nobody's come up with a model that's worth anything for any economic data. And so I would take the point that it'd be good or better if models were considered stronger. And there's some other problems as well. I'll glance over these or go quickly over these. So just in an overview of what the model gives you, right? It breaks things into independent impulses. I don't believe that in 1967, they considered a REMA, they were thinking regression models. And usually it's estimated some iterative or maximum likelihood process. And then it's often quite easy to get the seasonally adjusted data. You just, in essence, zero out or take away the seasonal terms. There's great differences between what the moving average approach does. One is things are simultaneously estimated. It's quite easy to add effects that are direct. You can take any of your candidate models and test them with conventional methods. You also get standard errors or measures of precision. And then this is a better framework to expand. If you want to be more systematic, compare indirect or indirect, do some aggregation up constraints, be Bayesian, it's easier to expand upon. So if we want to encourage this is what I would suggest, that agencies always give out not seasonally adjusted detail, and they give out enough detail that anybody could replicate official adjustments. They also have ways to show how they come up with outliers and making things more transparent. We'd also want to potentially, they might publicize some of these other ways to seasonally adjust. And then finally, my proposal or my idea was maybe go into or encourage an open source, open data world. And if you know, this has been like successful open source programming. And there are some examples where it's actually worked out for just data. And the way to think about the open source is you have a community as opposed to a hierarchy, or there's actually a famous paper called The Bazaar versus the Cathedral. The bazaar is messy, it's noisy, it's not controlled, while Cathedral is trite, fixed, and structured. And you can imagine there's some advantages to Cathedral, but it won't always come up with the best ideas that a noisy bazaar would. And I'll just list some of these. You get openness, better documentation. But the last part is this here. You get collaboration, collaboration, collaboration. People work together One of the ideas of why open source works for programming, that people do the work for free, and they want people to believe others outside of their work group to believe they've done things right. So they document very, very well, because they don't want to be bothered 2 years from now by somebody asking, why did you do X? They document it very well. And that's what encourages collaboration. That someone doesn't have to guess your steps. They have them see them written down. So there are some possibilities of being more open source, open data. I would argue that maybe our agencies could spend a little less time in creating tables and tables of pages and pages. Instead, make the process easy for anybody to run, to create the tables and reports that they want. Another thing you might get is free double checking. Other people will be looking completely outside your agency of what you're doing. And maybe this might have avoided the GDP residual seasonals problem. You also might get, or I would guess you would get, some library of what has worked. What has worked with exogenous factors, what has worked with best models, what type of system designs can be done, and maybe extra new ideas. And so I just believe being more open, this open data idea that's often taking off with other type of government data. It's worked quite well with COVID data, comes out daily, and people run forecasting models on it. It's been very helpful to county hospitals and county planners to see how hospitalizations might be hitting their area. And so I just believe it's going to be more seasonal adjustment research, and think about this as a way that has little disruption to official reporting. Because I do understand that really is the job of the agencies, to officially report the data they're collecting, and seasonal adjusted reporting is definitely better than allowing or assuming everybody knows how to seasonally adjust. So that's everything I wanted to talk about, and I appreciate any comments.
We've had some comments in the chat already.
Okay.
John posted a link to that, to the Shiskin Young Musgrave paper that you cited from the census website. Chuck mentions that this non-unique breakdown is an example of the blind source separation problem. And Tucker mentions that they weren't opposed to models per se, just regression models.
Yeah, I imagine that's exactly right. They probably were opposed to fixed trend regression models, which certainly have failed greatly. But that's right. And then maybe people take that meant we don't, well, I think it's great that X13 has this seats modeling, but it seems to be not used as much as I ever would expect it.
I agree with you, actually. I also agree. I agree with so much of what you said. You know, if
and that proves we're not in charge, right?
If agencies would even publish not rounded numbers or rounded less, I guess, because I spend a lot of time trying to reproduce seasonal adjustments from government agencies. And lots of times it's just a matter of they've run X13 on data that's has not been rounded. And then what they publish on the website is, and so there's no way to replicate without guessing what the number would have been. So yeah, anyway, yeah, no, I agree. I wish there was more transparency also. All right, but I will not take up all the comment time. Other comments or
and I see someone made a comment that X11 actually is a model. And I agree. It's just not parametric. There is some concept behind it.
Right. No, I think they really were referring to just regression models.
It's right, yes.
And Wendy, do you have your hand up? Did you need to? Yeah.
Yes, I did. Thanks. You mentioned a success for Androids. Was that on Android cell phones? And if so, could you give an example of that?
Let's see, where did I have my successes here? I think I have it up now.
Yes.
The Android system, as I understand it, is open source, and it can be modified. There is an official Google, but the source code of Androids, and that's why people have been able to write better applications for phones and be more innovative. This is just really areas where the software is developed open source concept as opposed to Microsoft-ish closed source.
Great, thanks. So there's not necessarily, I was thinking of, seasonal adjustment tools on an Android phone or something.
No, I did not mean that. I just meant that the open source idea has worked very well with some, the Apache server is probably the best example. Everybody uses Apache server. When you would have thought 30 years ago that Microsoft or Sun would have dominated this area.
Okay, thanks.
All right.
I'm going to pop in and say that we do attempt to have transparency behind what we do, and we do make spec files available, but other realms of statistics means that we have to protect certain time series that might be seasonally adjusted, but we can't publish them for whatever reason.
Sure, I've just glanced over that whole, it's easy for me to sit outside and ignore some of those issues, but that's certainly true.
I don't want to argue with Kathy because I love you, but a new home sold, if y'all would give us, the world, 1 or 2 more decimal places, it would make a world of difference. And it's not any kind of privacy issue. It's just, I don't know.
I do hear what you're saying. I do. It's just maybe this is one of those stovepipe kinds of situations. Like the decision for what is publishable is well out of the realm of what the seasonal adjustment reviewers are doing.
Oh no, I know. I understand.
Well, I know you know.
And I've tried to go up to ask for more decimal places. That doesn't work either. So yeah, I understand.
This is Bill Bell. Am I heard?
Yes.
Yeah, from what you're saying, there are competing factors here, which comes up in other contexts. If you want to do something like check results, you want lots of decimal places. If you want readable tables, you don't want lots of decimal places. And then there's the issue of how many decimals are really meaningful. So, for the different purposes, the ideal is different, which I suppose means if you had numbers in a spreadsheet, say, and you can control the number of digits given, then you can potentially make everybody happy, I suppose.
Well, and I think that's part of what Michael was saying, right? If you have a way for people to generate their own reports, then you could get something with no decimal places that's readable. I could have more decimal places because I don't care if I can read it. I'm just going to download it and run it through X13. So yeah, no, I agree.
Right, I think the issue is often the distributed data is made to completely agree with the tables. And that's where the decimal problem. Maybe the rule is, can Kathy replicate to her satisfaction? That's enough decimal places. And it's certainly 1 decimal place for unemployment rate is not enough.
Right. Yeah.
But that's what the data will spit out, because that needs to agree with the table. And it really should be the other way. The table agrees with the data.
Yeah.
Shouldn't be the data agrees with the table.
I agree completely. All right, we need to move on though. Thank you so much, Michael, and for everyone who left a comment. Thank you.